Kingsa.com.
Hello. Welcome to the lesson on JavaScript functions. Now, other computer languages may call these things methods or procedures or subroutines or subprograms, but in JavaScript, we definitely call them functions. The basic idea is to break large problems into small problems. In math, they teach you, when presented with a large problem, break that math problem into smaller pieces and solve the smaller pieces. Computer programming is no different. We never want to program in one giant block of code. We want to break that code into smaller pieces, smaller functional pieces. I've boxed out a JavaScript function here, and you can see we use the keyword function when we're declaring or creating a function. So there's no doubt what we call it in JavaScript. Again, other languages might call this a method or a subroutine. JavaScript, we call these functions. Basic idea on this slide is I've got a set of terms there at the bottom of the screen. And on this generic code, I'm going to go through and explain all the terms that relate to functions. First up is the header of the function. What is the header? The header is where we declare the function. When we type out the code that says we want to build a function right here. So you can see the function, any function with a parm1 parameter. This is the header of the function. Not really an executable line of code, more of a declaration of the function. Next up is the body, or the body of the function. This is the executable code. This is the code that will execute when we call the function. You can see it's the code between the curly braces of the function. See that starting curly brace at the end of the header? See that closing curly brace at the end of the function? Any code inside those curly braces is the body of the function. Next up is the call to the function. In this line of code, we are calling the method anyFunction. It's going to jump and execute the code up here. This is called the call to the function. Often beginners get the call to the function and the header of the function confused. But in JavaScript, it's pretty easy. The header will always contain the keyword function. The call will not. The argument to the function. It is a value passed to the function so it can do its job. In this case, we're going to pass 27 as the argument to any function. Next up is a parameter to a function. Parameter is what we call it inside the function. This parm1 is the parameter to any function. The 27 will be assigned to this parameter. The return type. In this case, the return type is int. In many computer languages, you have to explicitly declare, I'm going to return an int, or a double, or a char. In JavaScript, you do not have to explicitly declare the return type. However, if you do return a value, it has a type. In the case of 0, it has type integer. So this function will return an integer to a caller. That's very important if you're going to assign the return value after a function call. So the return type in this specific case is going to be integer because the thing we're returning is an integer. Slightly different is the return value. The return value in this case is 0. Remember, when you're talking about variables, there's values and there are types. In this case, the function also has that same issue. The type that the function returns is int. The value in this case that the function returns is 0. Let's trace some code and see how it works. Again, this is very generic code. I want you to focus on the mechanism of calling and executing a function, not on a specific application or purpose. We're going to execute any function and pass it the argument 27. This is clearly the call to the function here. And notice how the 27 gets passed to parm1. So the 27 gets passed to parm1. You can see over here in RAM memory, parm1 now has the value of 27. You don't see an explicit assignment of 27 to parm 1, but it happens. It's automatic. The argument is assigned to the parameter when you call a function. The body of the function will then execute. Any code that is in between the curly braces will execute when any function is called. When we reach the end and the return statement, we will return a 0 to the caller of the function, so that 0 will be returned and supplied as the value returned from the call to any function. That 0 that was returned is then assigned to the return value. And you can see that that 0 showed up over here in the return value. It's pretty simple and straightforward. I sent it an input, 27, and it sent me back an output of 0, which I then assigned to return value. One thing I want to make clear is functions do not have to return values. Functions do not have to return value, but if you do not return a value, don't assign it to a variable. One of the purposes of a JavaScript function is to write once and use many times. One thing we don't want to do is repeat the same code over and over and over again. If we can isolate a piece of code to one part of the program and use it over and over again, that's much, much better. So updating the screen is a good example. I'd rather update the screen in one function than scatter screen updates all over the code. So we're going to write the code to update the score and the user's health on the screen in one spot. So we only have to maintain one spot in the code updating the screen. Write once, use many times. So here's the function update screen that draws something on the screen. What's the function header here? It's that line that contains the word function. What's the function body? It's the document.write line in between the curly braces. What's the function call? The function calls are below this box. The header and the body are in the red box, but the function call is farther somewhere later in the code where we execute update screen. So the function calls are down here. There's a function call, there's a function call, there's a function call. Here's the function header, here's the function body, and there's a function call. So let's trace this code and see how it works. Again, what we're trying to do is update the screen. That's a common function in video games where we need to go update and tell the user, what is your current score? What is your current health value? We'll call the function update screen. This is the function call. The arguments are going to be 0 and 100. 0 will be assigned to the parameter score2. 100 will be assigned to the parameter health2, and you can see over here that score2 and health2 get their values of the arguments. Now let's execute the body of the function, and we'll go out to the screen and we'll write to the screen the score colon is score2. See that 0 in score2? That's why it's showing up down here on the output. See that 100 in health2? That's why it's showing out here in the output. I want to insert at this portion of the output the value of score2 and the value of health2. That is the body of the function. We hit the end of the function. Notice that there's no return value here. This function does not have to return a value. Notice how when we called update screen, we did not assign the return value. So when this function is done completing, it will return to the line of code after the call to update screen, which is right here, and we'll execute the line after the call to update screen. Now what you have to understand here is, see these red X over here? I crossed that out because these variables are now going to be deleted. After the call to the functions, the parameters are deleted. We're back into the main program and using different variables. Score is set to 20, so you can see a 20 is set to there. Health is set to 72. You can see health is set to 72. And I'm going to set up these two variables and call update screen again. What's the difference on this call to update screen? On this call to update screen, I'm passing as arguments the values stored in variables. On the original call to update screen, maybe the first one, the initial one, I passed it hard-coded values for arguments, 0 and 100. It is better programming practice to pass the values of variables as arguments to functions. So I'm going to pass the value in score, which is 20, to the variable score2. And you can see the value in score got passed to score2. And I'm going to pass the value in health, 72, as a parameter argument, and health 2 has a 72. That's the only difference here. I'm passing the values of these variables rather than hard-coded values. Score 2 has the value 20, so a 20 shows up on the output. Health 2 has the value 72, so a 72 shows up on the output. When we're done executing update screen, we'll hit the end of the function. When we hit the end of the function, we'll execute the line after the call to update screen. The line after the call to update screen is another call to update screen. This time I'm going to send my arguments slightly different. I need to send a number to update screen. How I get that number doesn't matter. Here I sent a hard-coded 0. Here I sent the value of a variable. Now I'm going to do a little math and send the result of that math. So score currently contains a 20. If I add 10 to 20, I get 30, and I send 30 as the argument to the parameter score2, and you can see score2 has a 30 in it. I'm also going to do a little math on health. Health currently contains a 72. I subtract 4, and I pass the argument 68 to health 2, and you can see a 68 showed up in the parameter health 2. So when the body of this code executes again, once again we'll have completely different values in the parameters. Score 2 contains a 30, so a 30 shows up in the output. Health 2 contains a 68, so a 68 shows up in the output. See what parameters provide? The parameters provide the ability to send different values to update screen every time it's called. As the game progresses, you expect the score and the health values to change quite a lot. And every time they do change, we'll call update screen, and in one location, one time, we'll update the health and score values. When update completes, we'll exit update screen and go to the line of code after the last call to update screen, which says we're going to wrap up our code. So let's say there are 100 places in the code where we update the screen, where we want to update the score or the health values on the screen. If we directly change the screen in 100 spots, that's 100 lines of code we have to change. But if we isolate our screen update in one code and we want to change or switch our language to Spanish, that is one function we have to change, not 100 lines of code. Remember, if I change this one line of code right here, if I change that one line of code, every call to update screen, be it 3 calls to update screen or 100 calls to update screens, they will all now output in Spanish. I use Google Translator to do this, so I hope these are the proper words in Spanish. Now, we'd much rather change this one line of code than change 100 different spots in the code where we were updating the screen. That's why we do this. We isolate the code in one spot. Let's say I wanted to write a version in French. If I want to write a version in French, again, I use Google Translate to come up with this new language. I change one function, rather than 100 places updating the screen. One place has to change. So that's why we want to isolate this code in one function. It makes it much easier and maintain the code when we write using functions as opposed to changing the screen 100 different spots in the code. Now I'll switch it back to English now, and you can see that writing with functions is a good, solid programming practice. Rather than writing giant blobs of code, split your code into tiny, small pieces. Parameters and return values. Understanding parameters and return values is important for understanding functions. Parameters are input, return values are output. So here's the parameters. In the case of this function, calc damage, my parameters are going to be arm and damage. So my parameters are in the parentheses of the function header. That's where I see where my parameters are. They're in the parentheses of the function header. There is an optional return value. Not all functions need to return a value, but there is an optional return value. This function clearly has many return statements in it. So this function not only has parameters for input, it provides a return value for an output. Let's trace some code and see what happens. We'll start with some initial values in some variables. We'll have a health variable with 93 in it, an armor variable with 55, and a damage variable with 8.0 in it. Let's start with those values and call our function. So we're going to call the function calc damage, and armor will be passed as an argument to the parameter arm. Damage will be passed as an argument to the variable damage. Whoa, what is that? This variable damage and this variable is called damage? Turns out that's okay. Parameters are considered local variables. So this is technically not the same variable. You can see I have a damage variable here that has 8.0 in it, and I have a local variable damage that has an 8.0. Consider this to be the function's damage variable. So both arm and damage get the values passed to them as arguments. Let's execute the body of calc damage. If arm is less than 10, well, arm, as you can see, has the value 55, and 55 less than 10 is a false statement. When the if portion is false, we skip that code and go on to the next statement. When we go on to the next statement, we'll look at arm less than 60. Well, arm currently has the value of 55. 55 less than 10 is a very true statement. As a true statement, we're going to enter the code of the if statement and execute this return. Turns out, if we have very little armament, we want to take full damage when we get hit. If we have some armament, medium armament, we want to take half the damage. So what we're going to do is we're going to calculate slightly less damage. The more armor we have, the less damage we should take. So that's what this function is doing. It's calculating how much damage the player should take depending on the amount of armor. So if the original estimate was it should be 8 amount of damage, we're going to cut that in half by multiplying it by 0.4. The result, 4.0, is what we return to the user to say, this is the much damage I want you to take. With a return of 4.0, we're going to use that in the health calculation. Notice how we didn't subtract 8 here. We had enough armor that we shouldn't take full damage, so we lowered the amount to 4, and 93 minus 4 is 89.0. After doing the calculation using the return value, that 89.0 is reapplied to the health variable, and you could see our health value went down. Does that make sense? That's a pretty common thing in video games. The more armor you have, the less damage you should take. And in this case, where we have a medium amount of armor, we calculated it to be half damage. Let's try it again and maybe we'll see it a little more. Let's run it again. Let's put some new values in the variables armor and damage. Let's put 92 in armor. That sounds like a lot of armor. And let's put a 10 in the variable damage. So whatever happened to our character, we want to subtract 10 points or 10 damage points from their health. We'll pass the current value of armor, which is 92, as the argument to arm, and you can see a 92 showed up in the parameter. We'll pass the current damage value as an argument, 10.0, to the parameter damage, and you can see the 10.0 showed up there. Now in this case we have a lot of armor, so I don't think we're going to take too much damage. 92 less than 10 is a false statement, so we'll skip that if. Go on to the next one. 92 less than 60 is still a false statement, so we'll skip this if and go down to the next one. 92 less than 95, however, is a true statement. We have a lot of armor, but not full armor. So let's just take a small amount of damage. We'll go inside the if because the condition is true. We'll execute damage times 0.01. Well, our original damage estimate was 10.0. We only want to take 10% or 0.1 of that and calculate a new damage value of 1.0. We will then return that 1.0 as our damage value. When we have 92% of our armor, we're not going to take too much damage. So our health variable currently contains an 89. We will subtract our reduced damage value of 1.0 and we'll get a new value of 88. That 88 will be assigned to our health variable, and you could see when we have a lot of armor, or 92% of armor, we're going to take very little damage. That's another reason why we use functions. Functions can perform a task over and over and over again based on differing inputs. The inputs in this case are how much armor do we currently have? That's changing constantly through the game. How much damage did the current attack do to us? And let's subtract from that damage in the cases of where we have a lot of armor. You can see if you go back to the original code, if you have more than 95% armor, you take no damage at all. If you have very little armor, you take full damage. That is a good example of when you want to use a function. In one spot, we can figure out how much damage to take. Global versus local variables. Now that we're getting into this idea of functions, we have to worry about something called global variables. Global variables are declared hopefully at the top of your code, and they're used throughout all the functions. Local variables are declared inside of functions, and they are owned, controlled by, and only used by that one function. So let's look at the difference between global and local variables here. Let's declare a couple of global variables here. I'm going to start to use the keyword var more. I think the keyword var is very important. In other computer languages, you need to declare your variables. In Java and C++, you have to say X position is an int, Y position is an int. So in order to kind of be consistent with that, let's always now use the keyword var when we intend to declare a new variable. So I'm going to declare a var X position equals 0. And a var y position equals 0. Let's call this the declaration of the variables x position and y position. Now, if these are declared outside of a function, hopefully at the top of your code, they're what's known as global variables, and they will be usable in all the functions that follow. Now, you can also declare variables inside of functions. Parameters are considered variables declared inside of functions, so xdiff is declared inside of movex. Now we're going to do a var xnew. We're declaring xnew by using the keyword var inside the function, so this is considered a local variable. Global variables are declared outside of functions. Local variables are declared inside of functions. Let's start using the keyword var to make it clear that we are creating a new variable here. JavaScript has this little glitch into it, this little nasty habit of if you don't use that keyword var, it is not a local variable. If I left off that var, xnew would be a global variable, not a local variable. So if we definitely want this to be a local variable, use the keyword var. Again, I'm getting to the point where if I'm declaring a variable, if I'm creating the variable the first time, I use the keyword var in front of it. Notice down in move y, ydiff is a parameter. Parameters are considered local variables. Ynew is a local variable because I use the keyword var in front of it, and only because I use the keyword var in it. When I declare a variable inside of a function and use the keyword var, JavaScript makes that a local variable. Try to do this with everything that you intend to be a local variable. Use the keyword var in front of it to declare that variable. It's only the keyword var that makes ynew a local variable. What's the difference between a local and global variable? Let's trace some code and see what happens. Let's say some code has put the values 5 and 580 in X position and Y position. These are constantly updating as the program goes along. They're changing at all times, so currently right now, X position and Y position contain a 580. Let's execute this code and see what happens. We'll call moveX and pass it a -8, which means we want to move -8 on the x-axis. As an argument, -8 is assigned to the parameter xdiff, and you can see that the -8 showed up as the value of the parameter xdiff. Remember, the argument -8 is always automatically assigned to the parameter, in this case xdiff. So there's our -8 showing up. Now be careful when you look at this. When we do this calculation, we are going to be using a global variable x position and a parameter or local variable x difference to do this calculation. X position, the global variable, has a value of 5. X difference, or x diff, the local variable or parameter, has a value of -8. So we're using the 5 here and the -8 here to do our calculation of -3. Now what do we do with that -3? We're going to assign it to the local variable xnew. Xnew is a variable that is created as part of moveX, and it only exists inside of moveX. So that -3 gets assigned to the local variable xnew. Now there's a problem with the value -3, and that is it's off the edge of the screen. If you consider the left side of the screen at X position 0, if you go beyond the screen, your character is moving off the edge of the screen. And it turns out we don't really like that. So we're going to do a little test here to see if the new value for the player's X position is good. So we'll ask if xnew is greater than 0 and xnew is less than 800. Is it within my screen boundaries? In the case of -3, it isn't. -3 greater than 0 is a false statement. As a false statement, it makes this whole thing false. When it's false, it chooses to skip the if and go to the end of the if. What we're testing here is, did the character go off the edge of the screen? And the answer was yes. If it happened that way, do not change the character's X position. Skip this code, forget about it, and leave moveX. So what we're doing here is making sure our character stays within the boundaries of the screen. When the character goes off the screen, we do not change its X position. We'll exit moveX and we'll move on to the program to the call after moveX. MoveX is done. Notice how the local variables got deleted. Local variables only exist while MoveX is running. They disappear when MoveX is done. Global variables, however, stick around the whole time. Nobody has deleted these variables. Global variables stick around. Local variables go away. Global variables stick around. So let's run MoveY. Notice that the global variables haven't changed. We still got a 5 and 580 in them. We'll do another call, MoveY, and we'll pass it the argument of 5. So we want to move on the y-axis by 5 pixels. You can see the argument 5 was sent to the local variable or parameter ydiff, and a 5 showed up in that variable over there. You'll also see we dynamically created the ynew variable over here. We haven't done anything with it yet, but we dynamically created that variable. That's an interesting thing about local variables. They get created when the function is run. That's why we created ydiff and ynew there. And they get deleted when the function is done. Local variables are created and deleted on demand. And since move y is running, its local variables got degraded. Again, we're sort of mixing here. We've got y position, which is a global variable and contains 580, and we're going to add to it the local variable or parameter y diff. 580 plus 5 is 585. 585 that we calculated gets assigned to the local variable y new. There's a 585 there. We'll test it to see if it's good. We're working here on an 800 by 600 screen. So if our y new value of 585 is greater than 0, that's a true statement. And our new value, 585, is less than 600. These are both true. The AND operator says if both sides are true, this whole thing is true. If this is a true statement, that means our y value is legitimate. Our y value is good. And look what happens. We're going to go and execute this code, y position equals y new. Since the if statement was true, we will execute the code after the if. Y new, which is 585, is verified and good. We'll assign it to the y position variable. And you can see y new from the local variable got assigned to y position, the global variable. We changed the global variable because move y did it in a proper boundaries. We want our character to always stay on our 800 by 600 screen. That is a legitimate value on an 800 by 600 screen. When we're all done with move y, we will exit move y and continue the code after the call to move y. Notice what happened to our local variables. Local variables disappear in between function calls. What doesn't disappear? Global variables. Global variables do not disappear. Global variables are declared outside of a function, hopefully at the top of your code. Local variables are declared inside of a function. Remember, parameters are local variables. So these are local variables. There are three major differences between global and local variables that you've got to get used to. Number one, globals are declared outside of a function, hopefully at the top of your code. Local variables are declared inside of a function. Number two, globals have a scope of all functions. When you declare variables to be global, like x position and y position, they can be used in any function. If you went on to write 50 functions, these two variables would be good and usable in all 50 functions. Local variables are only good inside their own functions. Variables like y new are good inside a function move x, but they're not good in the other functions. Variables like y diff, which is a parameter, are only good in move y. You cannot use this variable in other functions. Finally, globals have a lifetime while the program or web page is running. These global variables x position and y position are created when the program runs, when the web page is loaded, and they do not go away until the web page goes away, until you stop running the program. Local variables, however, are created when the function runs. As soon as it starts to execute, that's when the local variables are created, and those local variables go away when the function is ended. So those are the three major differences between globals and local variables. Hopefully you understand them better now. Pass by value, or make a copy of the argument. What's going on there? Well, pass by value is sometimes called called by value. Depends on the book you read. Somebody call it pass by value, some call it call by value. But let's look at it and let's visualize it and see how it works. First up, I'm going to declare a global variable called money. This is how much money the current player has on hand. We'll initialize it with the value 20, and that is a global variable. This is declared outside of a function using the keyword var. It is a global variable. Now let's write some code that executes from the main page or from another function. Let's output to the screen money before plus money. So this is a global variable. It's going to grab the 20.0, and the money before I make the call has 20 in it. Seems simple enough. All we're doing is printing the contents of this global variable. Now let's call a method called display money. This is the call. So we'll pass it as an argument the value 20.0. So 20.0 is the argument that will be assigned to the local variable cash. Now as a local variable, cash is a copy of the variable money. See the 20 that was in money? It got copied to the local variable cash. That's why it's passed by value. We're making a copy of the value in the variable money. Since cash is a copy, it will have the same value as money at the start of this method, and our cash on hand will print it out, and cash on hand, the 20.0 in the copy, gets sent to the output of the screen, and it says cash is 20. If money was 20, cash is 20. But now we're going to change the parameter. We're going to say cash equals 0.0. We're going to take away all the money. We're going to be changing the copy. Notice what changed to 0. The copy changed to 0. So this changed to 0.0. What did not change? The original variable, money, which was passed, did not change. Cash is a copy, so we changed the copy. We did not change the original. So if we were to print out what the cash was, we'd see 0.0. However, the reason we like pass by value is that when we return from the method, watch what happens to the copy when display money is done. The copy, which contains 0.0, watch what happens when we return to the code that called display money. The copy disappeared. The 0.0 went away. What didn't change? The original parameter. We like pass by value because I can send this as a parameter, and if it contains 20 before the call, it will, I guarantee you, contain 20 after the call. So when we print out money after the call, you can see the 20.0 showed up. That's what pass by value means. You can pass a global variable or any variable as a parameter to a function and not worry about the value changing. If the variable money contained 20 before the call to display money, I guarantee it'll contain 20 after the call to display money. That's pass by value. In pass by value, the parameter is a copy of the variable passed. No change can happen to the original variable. This cash equals 0.0 never touches the variable or the value money. Basic data types like ints, doubles, and chars are passed by value in JavaScript. There's also something called pass by reference, where the parameter is not a copy of the variable passed, and that can change the original variable. I haven't shown it to you because we're not ready to study it yet. Objects are passed by reference. We'll do more on this later when we get to objects. There's no sense showing you pass by reference until we get to objects. For now, keep in mind that simple data types like ints, chars, and doubles are passed by value. The parameter is a copy of the variable passed. And we'll do more on pass by reference when we cover objects. Globos versus parameters. The two ways to send information when writing a function are, for input and output of that function, we could use option A. Use a parameter and return value to send input and get output from a function. And option B, we can use global variables as input and output to a function. So here's a very simple example designed to show the difference between the two different techniques. First, we'll create a global variable called level, right? This is the game level we're on. We always start the game at level 1. That's why I initialize it to a 1. So at the very beginning of the game, our player is at level 1. Now let's look at both ways we can access and or change that variable. First up, let's use option A. Let's use a parameter as input to the method. So I'm going to send the global variable level as the parameter or argument to lev. So it currently contains a 1. The 1 will be passed as the argument to the local variable lev, and that you can see the 1 was copied to the parameter lev. This is a copy of level. It is not level. We're going to operate on that copy. We're going to say lev plus plus, which says add 1 to the variable lev and store the result back into lev. So this will change lev to 2. Remember, that's a copy. Look at the original. It stays the same. We will then return lev, the value in the local variable. So we'll send a return value of 2 back as output from the method. Remember, anything we return is output from the method. We'll send that 2 back to the calling routine, and the 2 gets assigned to the global variable level. Again, we're doing option A, using parameters and return values for input and output. So the 2 that was returned was assigned to the global variable level, and you can see it updated to 2. What happened to the local variable lev, the parameter lev? It disappeared. We don't need it anymore. Once that 2 was transferred to the global variable, the local variable disappeared. Did you see it? We set a 1 as input to this version of bump level, and we got a 2 back as output and assigned it to the global variable level. Well, now that we understand global variables, you don't technically have to do it that way. We're now going to look at option B. We're going to use the current value of the global variable 2 as what we call an input dot precondition. Before we call this version of bump level, this one without parameters, see there's no parameters here, there's no parameters here. We're not using a parameter as input to this method. What are we using as input to this method? We're using the global variable. Since global variables can be accessed anywhere, we're going to use the global variable as our input. And see that level right there? That's going to be the current value of 2. That 2 that's in the global variable level, we'll add 1 to it and get a result of 3. Now notice we're using option B. Level 2 was set before the method call. The value in the global variable is input to this method. 2 plus 1 is 3, so we'll take that 3 and assign it back to the global variable. Again, we're using option number 3, using our global variables as input and output to the function. The global variable was set to 3 after the method call. It becomes output, or what we call the post condition. Those are the 2 techniques for sending input and output to and from methods. Before the call, level was set to 2. It was input to bump level. After the call, level was set to 3. It becomes the output of the method. Those are the 2 techniques for sending input and output to and from methods. Number 1, parameter and return value is better programming practice. When given the choice, all things being equal, try and use parameter and return value as input and output to the function. It's considered much better programming practice. Number 2, use global variables sparingly. Too many is too much. You do not want 1,000 global variables at the top of your code. You want to have a small, concise list of global variables. So very, very critical information like the level or the X or Y position of the character, that might be global variables. But temporary variables, variables that you only use occasionally, try and use locals or parameters for those. It's one of those things I know when I see it. When I see hundreds and hundreds of global variables, I know you're doing them too many. Experience is the best teacher. As you program more and more and more, you'll get a little better at when I should use global variables and when I should use parameters and local variables. Have patience is what I'm trying to say. It becomes clearer over time. Parameters and return values are considered better programming practice than using excessive global variables. A lot of times it comes out down to how many times you're going to use this variable. X and Y position are used over and over and over again, so we declare it global. If it's something like an intermediate calculation like we did with calc damage, you might want to use a local variable for something that's only used once or twice. Good luck. See you on the next lesson.